One of the nice things about renewable natural gas is, like electricity, it takes advantage of this massive distribution system that we already have. So you can easily connect the energy source at the biogas or landfill gas project with the natural gas users who are spread all over the country. Natural gas is not as widely distributed as electricity, but there's still very good natural gas interconnection to a lot of consumers in Canada, at least. To be able to use this system, you need to be close enough to a suitable injection point on the grid, and that connection point needs to be connecting to a pipeline that's like the right capacity in terms of size and pressure to accept the amount of gas that you'd like to put in it. So this requires coordinating with the natural gas utility in the area, and where there isn't a sufficient pipeline, you might have to build a longer pipeline to a place that is sufficient to inject it, or you might not have a feasible option for actually getting into that grid. So similar to the electricity options, if you don't have a suitable grid infrastructure to receive that energy, you have to look for another way to use that energy. It won't be easy to put it into the grid. Some of those other ways are, one is called a virtual pipeline. So rather than having a physical pipeline moving your gas, you will compress the gas, put it on trucks, drive it to a location where you can put it into the grid, and then depressurize it and inject it into the grid. That's called a virtual pipeline. You can also, we're putting gas onto trucks. Why don't we just power trucks with gas? So that's another thing you can use. A lot of trucks are now able to work on compressed natural gas. And this has two benefits. One is compressed natural gas vehicles are just more efficient, lower carbon emissions than gasoline and diesel vehicles. And then second, if we're using renewable compressed natural gas, then we have, according to greenhouse gas accounting principles, all our emissions are biogenic CO2, so they wouldn't count at all. So there's two benefits of using compressed natural gas vehicles. And with all these systems of using renewable natural gas, the attributes of the gas itself, so the fact that it's saving emissions by emitting biogenic CO2, don't necessarily have to follow those exact molecules. So I can generate RNG in Edmonton, and I can virtually buy it in Ottawa and say, okay, I'm actually using the gas in my area of the grid, but I'm paying for the gas in your area of the grid. So I'm going to take those greenhouse gas savings attributes. This is a technique called wheeling. So you're not physically consuming those molecules, but because those molecules are coming into the system, it doesn't really matter that you're not using them physically. This allows users and consumers, generators and users on other ends of the system to buy and sell gas to each other and trade those attributes. So they're fungible across the system, which allows premiums that might be offered for renewable natural gas in some places to fund projects in other places, which is helpful for project development. In Ontario, Enbridge, which has the monopoly on natural gas distribution in Ontario, was recently approved in fall of 2020 to offer a premium for renewable natural gas through a voluntary program. They haven't started funding any projects with it yet, but utilities in BC and Quebec have. So those utilities are actually driving a lot of the development in other projects through this act of wheeling the attributes from the RNG. So the actual molecules don't actually make it probably all the way to Quebec or BC, but because it's going into the system somewhere, it's kind of pushing some of the fossil molecules out of the system elsewhere. And that's a way that we can connect to the market. For an example of a renewable natural gas project, this is in Quebec, the Société d'économie mixte d'énergie de la région de Rivière-du-Loup. In the picture on the right, you can see this project. So a lot of this picture is taken up by a big landfill. So this green area is the closed section. Here's the section that's still open. You can see some leachate infrastructure over here. And then up at the top, you can see the digester tanks, which are also shown in the picture at the bottom. So this project is taking advantage of both the food waste digester and the landfill. So two sources, landfill gas and biogas. So they're kind of able to pool resources. That's all going through a similar purification system, which is seen on the right side of this photo. And then because this area is actually in a pretty rural area, you might be able to tell just by looking at the surroundings. In this application, they're using that fuel for compressed natural gas vehicles that are coming to the landfill slash food waste facility anyway, and powering them with that gas, so they don't need to be interconnected to the larger system because they're out in the country. So that's how it works at this particular project. Now, renewable natural gas can help displace fossil natural gas on the grid, but there's also all sorts of other fossil fuels on the grid that we want to get away from using. So gasoline and diesel and bunker fuel for ships and things like that. And waste can plug into that system to some extent. Biogas and landfill gas have some of those building blocks that you can react in a chemical process to produce longer hydrocarbons that can displace some of those systems. So that use would be called gas to liquids. This is not very commercialized yet, but because there's so much material in waste, this is something we might see growing in the future. In addition to biogas and landfill gas as feedstocks, solid waste in thermal treatment technologies can also be used, and we'll talk about that when we get to our thermal treatment unit. So that waste can actually be turned into gas through a different process, gasification and pyrolysis, than anaerobic digestion. You'll get a different gas, but you can still use it as building blocks to build different hydrocarbons up, and you can have synthetic jet fuel and synthetic diesel and things like that. There's also a group of technologies called power to gas, where you're changing electricity from the grid into gaseous fuels such as hydrogen and methane. And this could integrate with a landfill gas or biogas project that's producing electricity that actually would be good to switch between the forms of electricity and natural gas based on the demands on the grid at the time. So this might be a technology that develops more with respect to waste in the future. Neither of these are widely commercialized yet, but kind of like I'm trying to show with this picture again, the energy system is very large and complex, and there's a bunch of ways we might see waste growing in it, and supplementing liquid fuels might be part of that. Allowing electricity to switch forms more easily might be part of that as well. We'll have to see. There's a lot of energy and material contained in our waste, in our biogas and landfill gas, as well as anything going through thermal treatment. So we'll have to see what's developed in the future. For now, direct use electricity and combined heat and power and renewable natural gas are the big ones, but we have a long way to go in getting to net zero emissions. So some of these other technologies might develop and use waste in the future.